All right, hey Honors Chemistry, I wanted to post one of two brief videos on the calculations that we talked about today requiring heat. We were all about trying to quantify energy, so now we have numbers. So just a quick recap from today, we came up with two equations. Q is equal to mc delta T, and we use this equation to solve for energy if there's a change in temperature. And the bottom one is Q is equal to mH, and we use this if I have a phase change. So if I'm trying to figure out my energy or anything associated with my energy, mass, specific heat, or change in temperature or energy phase change, I need to use these two equations. So let's look at one example, and I'm going to just use this example for this video, and I'm going to post another video on a similar example. This is similar to question number 1. This is not question 1, but it's similar to question 1 on your worksheet number 3. So if you want to try at home, try and do some of these questions, or if you have worksheet number 3 in front of you and you want to see and read question number 1, you can see how this is similar. All right, so I made this up, I just changed the numbers in the direction. So this question says, a cup of coffee, 200 grams of it, heats up from 20 degrees Celsius to 100 degrees Celsius without boiling, so no phase change. How much energy was transferred to the coffee? So, which of these equations am I going to use? Q equals mc delta T or Q equals mH? Let me figure out. Q equals mc delta T I use if I have a temperature change, and Q equals mH I use if I have a phase change. So if I quickly reread the question, a cup of coffee, 200 grams of it, heats up from 20 degrees Celsius to 100 degrees Celsius without boiling. So it looks like I'm not boiling. It also sounds like my temperature is changing. I'm going to use Q equals mc delta T for this question then. Why am I using Q equals mc delta T? It's because my temperature is changing and I'm not undergoing a phase change. Okay? So now let's identify our variables. So Q I'm looking for because it says how much energy was transferred. So Q is the question mark. M is my mass in grams. So let's see if this question gave me my mass. A cup of coffee, 200 grams. So I'm going to write down 200 grams. That's my mass in grams. Heats up from 20 degrees Celsius to 100 degrees Celsius. My other thing is it's a cup of coffee, and it's C. Coffee is mostly water. So I'm going to use the specific heat capacity of liquid water. The specific heat capacity of water is 4.18 joules per grams degree Celsius. And we all know that coffee is mostly liquid water with just crap in there. So my specific heat capacity is 4.18 joules per grams degree Celsius. And then delta T is the other part of this, is my change in temperature. And it says I'm going from 20 degrees Celsius to 100 degrees Celsius. If you could do this in your head at quick inspection, going from 20 to 100 is a change in temperature by 80 degrees. But just in case, delta T is T final minus T initial. And it looks like it's going from 20 degrees Celsius to 100 degrees Celsius. So my from 20, that's my initial temperature. And my final temperature is 100. So 100 degrees Celsius minus 20 degrees Celsius, that's equal to 80 degrees Celsius. That's my delta T. Now I'm going to plug and chug. I'm going to plug these values into the equation. Q equals mc delta T. I'm going to solve for Q because the question asked how much energy this is my heat energy, how much energy Q is associated with heating up something from 20 to 100 degrees Celsius. So Q equals, my M was 200 grams times 4.18 joules per grams degree Celsius times 80 degrees Celsius. And let me run and get my calculator. If I do the math, right, all I have to do is multiply 200 times 4.18 times 80. So I'll do 200 grams times 4.18 times 80, and I get Q equals 66,880. My units are going to be what for energy? My unit for energy is joules. So 66,880 joules. And if you weren't convinced that I got joules, grams cancels out with grams, degrees Celsius cancels out with degrees Celsius, and I'm left with joules. Now I want to make sure I have significant figures. Let's assume that I have decimal points next to all my numbers here. It looks like I have 3 sig figs with a 200. 200 is 1, 2, 3. I put a decimal point there, so 3 sig figs, 2 sig figs, 3 sig figs. It sounds like I need 2 sig figs for my answer. So how am I going to do this? My answer has 1, 2, 3, 4, 5 sig figs if I have a decimal point. If I want 2 sig figs, I'm going to need to round this or use scientific notation. If I round this, I'll get 67,000 joules with the 2 sig figs, or 6.7, 1, 2, 3, 4, times 10 to the 4th joule. All right, so maybe we forgot how to do scientific notation or round our answer to get 2 sig figs. You could watch an older video. But for this, my answer, I'm more worried with right now that you're getting 66,880 by multiplying mass times specific heat times the change in temperature. Okay, so I'm hoping this was a brief video, a brief review of what we talked about in class today. In class was a bit more involved. We did number 3 and there was like trying to solve for a final temperature. But this is very straightforward. My next video, I'll talk about what we do with a phase change.